Hello, everyone. Thanks for joining us tonight. I'm Wesley Chun. As Raju mentioned, I'm a developer advocate at Google, and my job is to basically speak to engineers like yourselves who are in the industry and basically show you all the different ways that you can integrate Google technologies into your apps. So tonight is a pretty special night. I'm not on the machine learning team. I'm not a data scientist, as I will show you in a couple of slides, but I'm here. I am happy to show you what I call an easy path in machine learning. Of course, there is no such thing as an easy, so I'll just say easier path, as well as introduce you to some other Google developer tools. We're gonna, if you have any questions that are burning, kind of like jot them on the note on the side, sort of like to yourself. And then if I don't actually answer your questions throughout the rest of the talk, please ask afterwards or plug it into the chat, and then I'll ask Raju to help me read some of the questions out of the chat. But after the whole session is over, next week maybe another burning question comes up in your mind. Then up here in the upper right-hand corner is an open Google Doc that you can just enter your question. Just go to the right event, because I do a lot of events, and so just jot your question there. And you can also it's an open doc, so you can also scroll down and see what kind of questions other developers have asked in the past as well too. Okay, so without further ado, let's get going. Okay, so a little background about myself. Outside of work, I'm a teacher, so I'm adjunct faculty at Foothill College. If you're from the San Francisco Bay Area, it's just really close. It's a community college here in Silicon Valley. But I also do private corporate training, and I also teach at schools. I give talks at conferences, so I'm not shy to get around. I'm also a writer, so if any of you know the Python programming language, we're going to show you some code samples using Python tonight. But you may have seen a couple of my books if you have learned Python over the last, I don't know, 20 years or so. But the most important thing about me is that I'm a software engineer. Probably the most well-known thing I've worked on. I was one of the original 10 engineers that built Yahoo Mail. I think there were 10 of us. It's hard to remember that far back, but that was 20 some odd years ago. And then I've done various startups in the Valley, and I'm currently at Google right now. Okay, so what is my mission? My job is to enable all current developers and future developers is kind of outlined in bold because my area of focus is actually higher education. So I spend a lot of my time speaking to university faculty as well as students to get them sort of up to speed on what cloud is before they enter the workforce. As you all know, knowing something about cloud computing is a necessity in our jobs today, even if we're just developers. So that's my focus, and that's why that's kind of highlighted. But the main idea is to enable all developers everywhere to be successful using Google Cloud and other Google developer tools and APIs. So I'm currently on the cloud platform team. For the past 5 or 6 years, I was on the G Suite developer team. So most of my content that you'll find online is related to G Suite. I will mention a few things on G Suite, but that's not the focus of our show tonight. My background is I've been a developer for several decades. I already showed you some of my background, but there's also a little bit about my academic background as well too. Okay, but so what are we doing tonight? So big data is everywhere, and there's so much data, and hardware has come down so much in cost that we can actually use machine learning today. So we all probably are aware that AI and ML have been, in the literature for decades, but it wasn't until recently that everything has sort of come together to make this thing real. One is that the amount of data that as society we're generating as a whole year after year, as well as the computing power to be able to sort of like tackle that amount of data. However, one of the tricky things is that it does require a certain level of sophistication as far as your mathematics and your statistics background. And so for those who don't, then the concept of AI and machine learning has somewhat of a steep learning curve. And that's kind of, it's kind of a deal breaker for a lot of folks, right? If you weren't trained that way, then it's really hard to come up with those skills, and it's not the easiest things to learn. However, we have APIs that can actually help you with this to help onboard you into data science and machine learning so that you develop the lingo, the vocabulary, the techniques, so that you can go, it'll just make the on-ramp easier to actually, going into, more deeply into machine learning. So the main idea is that if you can call APIs, then you can leverage machine learning. So the talk will start up with sort of a high-level introduction to machine learning. If you're not a developer, then this is perfect. Just for you. Once you can tell when I'm going to start getting technical and start talking about code, you can kind of tune out at that point. But for now, everyone's welcome to join in this high-level introduction. And then I'll talk about what Google Cloud is and what some of our tools are. And then I'll focus on our APIs, introduce you to how to use our APIs, and then spend the majority of the time talking about the machine learning APIs that we have to help, again, ease you into machine learning. And then I'll talk about other Google APIs that you may want to consider that may sort of augment the functionality that you want to build and whatever solutions that come to you. And then I'll show you a couple of example applications, maybe to serve as inspiration as to what you can do using our APIs, and then we'll wrap up with a summary, a bunch of links, and then of course the most important thing, a link to the slide deck, so that you don't have to take screenshot after screenshot or take pictures and stuff like that. So that's the agenda. So again, the caveat I mentioned earlier is that I am not a data scientist. When I was in school, and I was a computer science major, but I studied networking and distributed systems. However, like many of you, I've seen the rise of big data and have got caught up in the excitement of machine learning. So this is a kind of the story of my journey as well. But the most important thing is I know how to call APIs. Therefore, I think I can take advantage of machine learning. So that's the main idea. So machine learning is AI, NL, and ML put together to help make computers smarter, to help us understand more and get more insights out of data than we have in the past. So what things are easy for humans but hard to code? So that's sort of like the premise. How should we think about this? All right. So I always like to start off asking people a question, and that is, how many of you out there can tell the difference between a puppy and a muffin? I know it sounds really funny, right? And looking at these pictures, of course, as a human, it's probably pretty easy for you to tell the difference between a puppy and a muffin. However, if you were to get a computer program to do the same thing, you probably have to draw up, some rules and guidelines to sort of help the code figure things out. So let's say you know how to analyze images, writing computer code. Maybe, in an image of a puppy, you may be looking for eyes and maybe a nose and ears. And maybe for the muffin, it may look like a giant volcano with colorful paper around it, things like that, right? So those are some basic rules that you could probably code to help your program tell the difference between a puppy and a muffin. So what I'm going to do now is I'm going to change the pictures and ask the same question again, which is, how do you know how to tell the difference between a puppy and a muffin? Okay, notice just by changing images, I've almost changed the question on you, right? But I didn't, right? The question is still the same. However, it's a little bit more difficult now. The rules that we defined may no longer work, like searching for eyes and a nose and maybe ears. Maybe those things will give you a lot of false positives or false negatives, right? So rules is not going to be enough. So we need a little bit more than just rules, and that is experience. So at sort of its very core, machine learning is rules as well as experience. Okay, so how does your brain do it? So over, as you've grown up as a child to becoming an adult, you've seen enough cats and you've seen enough dogs where certain signals go through your mind that tells you this is a cat or this is a dog. And everybody goes through this. This is how you think. But in order to make sort of a computer think this way, we have to sort of simulate how the mind works, and that is developing all these layers where you're sort of like triggering. Part of it's going, I'm pretty sure this is a cat, and then you keep on looking at it, and then you develop more signals, and then eventually you come up with sort of like the decision as to what that object is at to a certain percentage, right? So that's how a human does it. But then once you have that vocabulary and that database in your head, that knowledge base of what is a cat, what is a dog, when you're given a new photo like this one, all right, you have to kind of like go back in your mind and start, using those signals that you've developed over the years to sort of tell you, is this a cat or is it a dog? Okay, cat and dog, this might be more difficult than a puppy and a muffin, but the thing is still similar, right? So you're trying to figure out what all these signals are that eventually lead you to that conclusion. And so this is sort of like kind of like a high-level summary of how machine learning works. So AI is sort of like a large subset that basically talks about how we can sort of simulate any kind of human intelligence using code. And then machine learning is sort of like a smaller subset of that, where you're actually making the code learn from experience instead of writing out explicit rules like we just described. And then on top of that, uh, we have deep learning, which is where you're trying to make the code itself get even better or smarter. So it's even, it's like self-learning. Okay, so this is sort of like a kind of like the onion, if you were to sort of like peel it back. So we're just kind of looking at it from the machine learning layer and not really going higher level or lower level here in this talk. Okay, so let's talk a little bit about machine learning at Google and how machine learning has improved our products. So the first one is your search app, of course, it's got a lot of machine learning in it, and this includes using a voice-driven app like the Google Assistant, or if the Assistant is running on a Google Home device or a Nest device, same thing like that. So it's not just your text, and it's not just words anymore. We're trying to figure out, what are you really trying to ask? And because a robot can't understand you, doesn't speak the English language, it has to parse what you say and sort of figure out what it is that you want. And so, based on having enough questions asked of it, it will have a better idea, as to what your actual query is. Another product that we've endowed with machine learning is Google Translate. So I don't know if you've noticed, but over the last few years, Google Translate has gotten significantly better. And that is, instead of like normal linguistic rules and things like that that we used to use in the past, now we're using machine learning and analyzing how people communicate in that language. And by knowing that, we're able to return results that are much closer to how humans speak. So Translate is another product, and then another product is Google Photos. So I don't know if a lot of people notice this, but if you actually go to your Photos app, there's actually a search bar at the top. And you never went and tagged all of your photos. You didn't say, these are the photos with my family, these are the photos with my pets. You didn't say anything like that. You just said, I want to search for dogs. And so um, the Google Photos service must have seen many pictures of dogs in order to be able to surface the pictures of dogs that are just on your phone or in your account, right? So all of these products have machine learning built into them. And if you were to look at, this chart is a little bit outdated, but you could see the sort of like the exponential growth in our internal use of machine learning to help improve our products for our users. Yeah, so anyway, so that's a little bit of a picture of machine learning at Google. What about machine learning outside of Google? What has ML enabled that was really, really difficult to do in the past? So one thing is phishing. So, and not the kind that comes in email. So this is actual phishing. So the premise is that, more than 1 billion people on the planet rely on having seafood as their meal. And unfortunately, 85% of all the fishing is happening in places where fishing is either not allowed, or it's regulated, or it's returning back to its natural state after overfishing. So that's not good. And even worse is that 20% of all the seafood that is caught is illegally caught, or it's unregulated, undocumented, and things like that. So that's not good either. And so it used to require like people, watchdogs, like checking satellite images and looking for this type of activity. However, the Global Fishing Watch Group has created a global map that is collecting a lot of data, and they're using machine learning to try and figure out, what are the kind of ships that are out there. Obviously there's certain ships that are for cargo only. There's, obviously, uh, you know, ships that are for fishing only. So you're kind of like looking for clues, basically. And then what kind of gear do these boats carry? And how, what is the pattern of the movement of these boats? And so using all this, you can kind of like figure out, who's really who's really who's really fishing and how much are they fishing and all that kind of stuff. So that's pretty useful. So there's a link there so you can click on it and kind of like find out what the hotspots are and things like that. So that's one example. Another one is this company where, they basically slice potatoes. However, there's obviously going to be imperfections in the vegetable that comes up. And so it'd be great to be able to find a way to detect all the ones that are bad. And so I don't know if this video will pull up, but let me just try it here really fast. If not, it's just basically a conveyor belt. Okay, here we go. So basically what it does is it scans all the vegetable cut up the cut up pieces, and it will actually register where something's good or something's bad. So anyway, so that's that. So that's using machine learning. How about if you just want to sort of like introduce yourself to machine learning in a kind of a light-hearted, fun kind of a way. So we have some fun tools that you can try out. Um, this one will probably be fun if you do this with your kids. So it's the Quick Draw program. So if you go down to the link at the bottom, it'll bring you to this website where for every game you play, this application will challenge you to draw an item, and then you have to draw it well enough so that our machine learning APIs can actually, assert that that is the actual item that you were supposed to draw. And so you draw 3 items, and then your game is over. It tells you how well you did, and then you can go and play again. So anyway, so this is pretty fun. So you can send your kids to that. And if you want to read more about this particular experiment, there's a link for you to learn more up here. I'm not going to do it, but you have time to do this afterwards. So what else can we do? Another experiment is this demo that we did at Google Cloud Next in 2016, where you can explore the world of images. So this is basically a galaxy of all kinds of images, and you can zoom into it. So the whole thing is 3D. It's pretty awesome. And as you get closer and closer, so anyway, so you launch it, and then you see this galaxy of all these different categories. And as you zoom in, it will actually, it'll actually point out other categories. So you keep on zooming in, you can go to specific areas, you can use your mouse and rotate and move in 3 dimensions. And as you get closer and closer to something like flower, as soon as you get to a planet, you'll actually be visiting a specific image of a flower, and then you'll see you'll learn. This will be the Cloud Vision API. You'll learn what our API sees in this image, and then sort of like some scores, like confidence scores, to indicate, what is the likelihood that this object is in the photo. So this is another fun app, so you can try it at the link down below, and then you can read more about this demo at the blog post, as well as get to the open source repo at the GitHub link there. Okay, so that's enough talk. How do we get started? So let's think about the first steps that we need to take. So the first thing is, a lot of people who are new to machine learning are like, okay, well, what is it all about? Well, I know I'm going to have lots of data. But the thing is, it's really hard in the middle. I'm going to have to, remember all my statistic stuff. Or if I don't have any kind of statistics or mathematical background, it's going to be really hard. And then whatever happens at the end, it's going to be pretty magical, right? So while this is, a somewhat true idea of what machine learning is, a little bit more of an accurate model looks something like this, where data is involved, and you're going to have to like collect it. And then what I don't have in between, which is really important, is cleaning it and then organizing it once it's cleaned. And then you create this thing called a model. So we'll talk about that on the next few slides. And then use machines to kind of like make this, to flesh out the model, or to sort of like make it better and better. And then finally, you can deploy this model, and then you can use it to make predictions on new data. So this is more likely what ML is. It's not, like I said, it's not too far off from this, but there shouldn't be as much guessing here. There shouldn't be as much, wondering like what is this magic? Okay, it is not magic. It is you're actually doing a lot of machine work, or having machines do a lot of work for you to make it seem like magic. Okay, so in order to have to be successful at machine learning, you have to have a lot of data. Obviously, if you only have 2 pictures of a cat and 1 picture of a dog, that model is probably not going to be that good. But if your model has seen 10 million dogs and 10 million cats, then chances are much better that your model is going to be accurate. So large data sets tend to lead to good models. Of course, if you have a large data set and all these examples are not so great, then maybe your models won't be great either, right? It's kind of like garbage in, garbage out type of thing. And then you need to have a lot of computation to actually build those models sort of in a time frame that's acceptable as a human and as a developer. Okay, so for example, if you were to work on detecting activity, like someone standing or walking, you may write some code that looks like this. If they're going less than 4 miles an hour, they're probably walking. If it's 0, they're probably standing still. Um, And then if people are moving faster, then maybe you will change your upgrade your code to if it's greater than 4, maybe they're running or jogging. And then if they're moving significantly faster, like maybe more than 12 miles an hour, maybe they're on a bike. And if they're moving faster than 30 miles an hour, they're probably in a car, right? So these are activities that you can kind of write some code to try and figure out. Uh, so these are like activities. One activity that's a little bit more difficult is golfing. So what do you do here? Because you're not moving at any particular speed. You could be moving at 0 miles an hour, which means you're standing still. You can be moving at 2 miles an hour, which means you're kind of like walking to the next hole. You're not doing any of these things. Okay, but I can't really use speed to be able to determine whether I'm playing golf or not, right? So there's certain things are a little bit more difficult to do. So maybe instead of measuring speed, maybe you want to take an image of people who are walking or standing still, or people who are running, or people who are biking, and people who are golfing. Then maybe you'll have a better chance of making a guesstimate as to what kind of activity a human is doing. Okay, so that's kind of an example. Seeing these rules and passing in data is an example of the traditional type of programming, right? You have logic, which is the rule, and then you pass in data, and based on whatever logic you have, and then the data that's passed in, you get some answers out of it. Okay, so that's kind of like traditional programming. However, with machine learning, it's going to be a little bit different because you need to have some of those answers to help you flesh out that model or the rules, right? So you need to have existing answers along with the data, and then output something that you can use to help you with new data. Okay, so machine learning requires just a little bit of tweaking your thinking to sort of like wrap your head around it better. Okay, so for example, again, instead of measuring speed, maybe I'm going to take a picture of somebody walking. So I, obviously encode it in a binary way, and I'll just say that is a human walking. Then I have another image of somebody running, then I'll say that is an example of a human running. And then similarly for biking, and then golfing, kind of, right? Because golf has lots of different things, a lot of different activities within the one sport. And so you may have to take a lot of different images of all the different things that you would do if you were golfing. Okay. All right. So anyway, so we have the answers and data going into machine learning and generating our set of rules, which is the model. So that is what is called training phase. Once you have trained enough, with enough data, and you're fairly confident with your rules, you would basically have a validation set or a test set to sort of like enforce or to validate the fact that your model is working. And then what you can do is you can move down to the inference phase, which is the predictive phase, and that's where you pass in new data. You ask your model, hey, what is this person doing, or what should the output be based on the previous data that I've seen before. So inference and predictions, that's what you do afterwards. Okay, so I'm going to start getting into code, and what you're going to do is think about like what would you do if you were asked to sort of like identify clothing. So instead of doing any human activity, it's about the things we wear, the things we carry with us, um, yeah, and basically identifying these items. So typically what people would do now, if you did have enough machine learning expertise, is you would go and pick a well-known library that's out there, like a TensorFlow with Keras, or a PyTorch, or scikit-learn. You basically pick a library to help you with this. So this one is an example from this is a TensorFlow tutorial that we have, so you can go check it out at the link here. And it uses Keras, which is a higher level library that sits on top of TensorFlow to make TensorFlow a little bit more digestible for people. But this is a well-known data set, and it's basically got 70,000 black, white, grayscale images, 28 by 28 pixels each. So there's a total of 70K, 60,000 are used to do the training, 10,000 are used to validate the model. And there's 10 categories of clothing, so different types of shoes, different types of tops, different types of bottoms. And you can just go line by line into this and learn how to use TensorFlow and do the training. It's great because it leads you through it, line by line, but you may not know what's in there. Again, if you don't have the mathematical or statistical background, you can certainly run the Jupyter notebook that it runs on, and you can just have the code running, and you can go and make predictions. You can change variables. It's great, right? So you may not be able to come up with something like that by yourself from scratch, but at least you'll have an idea of the process of training a model and then using it. Okay, so that's a really good tutorial. But not everybody, again, is ready for TensorFlow or any of these open source libraries. You can jump straight in. So this is like, once you're comfortable with machine learning and you're ready to go and build and train your own models, you will actually go and do a tutorial like this or multiple tutorials like this to actually go and do it. Okay, and that again sort of involves taking a data set, looking at it carefully. Here's a 28 by 28 pixel of a shoe. And then what would happen is, the Python code, if you don't know Python, just pretend it's pseudocode. It's going to be very similar in other languages. So you'll import the data model, you'll import the training images as well as the labels. So the labels is, the image is, this is well, I guess it's up here, this is a shoe. All right, and the label is, I'm just gonna label it as 09 is the shoe category. And then for shirt, that's gonna be a different category. So maybe that's 1, a sweater, maybe number 2 or whatnot, okay? And then the same thing applies for test images and test labels. So everything is identified. This is a shoe, and we actually say it's a shoe, okay? So this is an example of what is called supervised learning. And it's called that because you're actually, a teacher is there to tell you, hey, this is a shoe, by the way. There's also another type of machine learning model where it's unsupervised training, where you're not told it's a shoe, right? So I'll kind of like mention that a little bit later on, but just to give you an idea, it's a one model that's pretty popular is a supervised learning. And then it turns out that this is a boot type, and then you can have it in multiple languages as well too. So that's that. And then so we have a whole data set, and then what happens is you import the data set, you start to pre-process the data, and then you start building up the models, you set up the layers, you compile it, so it just gets trained with all 60,000 images, and then you test it with the test data set, and then you can go and find out, hey, is this a shoe? If it's number 9, then it's probably a shoe. So if you look up, you can't really see the slide that well, but this is on number 9. It's a shoe. This is a sweater, so it's number 2. These are a pair of pants, it's number 1. Here's another pair of pants, that's also number 1. So everyone's gonna fall in line. So all the predictions are falling in line with the training set that you gave. And then also some things may or may not be shoes. Like this one is actually incorrect. It actually identifies this as a shoe, but it's only 57% sure it's a shoe, right? So it may be something else, like maybe it's a sandal. It's so close to looking like a sandal that some of it has an intuition that it may be a sandal as well too. So anyway, so this is an idea of how machine learning works once you're in the inference phase. Okay, so that is it as far as sort of like the high level introduction to machine learning, but maybe you're not ready to go do all that stuff yet. So let's see if we can onboard you to machine learning in a slightly easier way. So let's give you a quick intro to Google Cloud and talk about some of the developer tools that we have. So what is Google Cloud? So Google Cloud is a bunch of machines sitting in some giant data centers that we have around the world. This one is a picture of the one, I believe, I think it's Oklahoma or Iowa, but I can't be sure. I haven't been to these. But anyway, so inside Google Cloud are all of our services that you're probably used to using, like Google Search and YouTube and Gmail. They're running on all these machines. One of the cool things is that our cloud is basically taking our technologies and sort of like making it available to all of you. So if you actually use our cloud and become a customer, then your app actually will run, in the same racks and the same machines. We don't have a special area or a special data center just for customer workloads. All of your stuff runs alongside our stuff. So anything that we do to sort of, make our machines more stable, to make our network faster, to make our services more reliable, all our customers get those benefits as a result. We don't differentiate between our workloads and yours. And if you want to learn more about our data centers, there's a link down there that you can take a look at. Okay, so what is Google Cloud? So Google Cloud has at least two, we have two large product groups that you're probably very familiar with. The first one is cloud platform. So that's the one I'm mostly going to be spending my time on. So this is the virtual, our collection of machines, big disk, machine learning, security, networking, all of those tools that you sort of expect in a cloud platform. And then we also have G Suite, which is Gmail, Google Drive, Calendar, Doc Sheets, and Slides. One caveat to G Suite is while people think that, oh, the left side is for developers and the right side is for users, that's not quite true because G Suite had, behind most of the G Suite applications, there's also a developer API. So you can actually code them as well as be a user. All right, so how can we help all of you? So obviously we have virtual machines and GPUs and TPUs, lots of big disk, as well as other forms of data storage. We let you create your own network, subnets. We have our pre-trained machine learning model, so that's what we're going to look at tonight. But we also have container hosting. We also give you the infrastructure to help you build the machine learning models. We also have a lot of serverless compute and data services. We can also provide additional or emergency compute and storage capacity. If you have on-prem, but you need backup just in case bad things happen, we're there for you. And then, of course, you're already familiar with all the productivity tools in G Suite. Okay, so we're going to take a look at the building block APIs. There are 6 of them. And so just, high-level overview as to what they are. We have the Vision API, the Video Intelligence API. We have a pair of speech APIs, speech to text and text to speech. So I'll go over each of these in a little bit more detail. We have natural language, and then we have the API for Google Translate. So so what are these APIs? So basically, as you sort of got the hint, when you're doing machine learning, you have to go through collecting of the data, building and training of the model, and then you have to validate it, and then you can make predictions, right? Everybody understands that flow. However, not everybody has the skill set to do the building and the training. So what these APIs are is we're taking models that have already been created by Google. So what we call these pre-trained models. So these were models developed at Google by Google, by my colleagues on the Google research team or the Google Brain team. And what we're doing is we're putting them behind an API so that when you call the API, you can go straight, you're going straight into the inference and the predictive phase. You're skipping all of the training. You're just using our models. And you can give us some data, and then we can tell you, we give you predictions on that data. Okay. And so this is using the same technologies as what powers our products that I showed you earlier. And the best thing about these is that you don't have to have any knowledge of machine learning in order to take advantage of it. So, the bottom line is if you can call an API, then you can leverage the power of machine learning. So if you want to learn more about these APIs, there's a link down at the bottom. Okay. So what are some of the other products that we have? So we're focusing on the ML API. So on the left side of the spectrum here, I'm going to sort of like look at this from the application developer perspective. We're not data scientists, but if you were a data scientist, you would start to, depending on, what level of a data scientist you are, you're going to start sliding over to the right. And then at the very right-hand side, you are a full-on data scientist. You are using PyTorch or TensorFlow. You are building and training your own machine learning models with your own infrastructure. You're getting your own GPUs, you're getting your own TPUs, and you're doing everything yourself. And apparently you have some DevOps and sysadmin skills, okay? So that's the other end of the spectrum. Maybe you are a data scientist, but you don't want to worry about the hardware, about setting things up, about getting GPUs. So we have another product called ML Engine, which is part of our AI platform, which handles all of the hardware work for you. So yes, you can still build things with TensorFlow, scikit-learn, PyTorch, but you don't have to think about the hardware. So ML Engine handles everything for you. It gives you a fully managed infrastructure with which you can build, train, and deploy your machine learning models. And then as you make our way towards the left again, between being an app developer and a data scientist, you may be sort of like in the middle, okay, where you're kind of new to machine learning, you know how to use the APIs, but you really want to start building and training models, but you're not quite ready for it yet. You're kind of starting to look into TensorFlow and PyTorch, but you really aren't fully ready yet. So we have a product for you, and that's called AutoML. So I'll go over that as well. Okay. So what are Google APIs and how do you use them? So first of all, everybody knows Google for our applications, right? You know Google for Android, for search, YouTube, Chrome, and Gmail and Drive and all of these other apps. But you can't wait for Google to write all the apps for you. We just don't do that. That's not something, that's not a service you can wait for us to do because we're not going to be able to write all the apps that the world needs, right? So we're relying on all of you to help with that. But we don't want you to have to reinvent the wheel because that's too much, right? We put in a lot of work, a lot of man and woman hours to build are to build up our technologies, and we want to share them with you so that you don't have to go and do things yourself. So Google is much more than just applications you use. We make our tech available for you. So all these come in the form of our APIs, our developer platforms, our developer tools. All this is to help you. So the next time you write your next web app, your next, the next idea for a company, web app, mobile app, or probably both. That's probably more likely, right? You can use these APIs to help you to not reinvent the wheel and just stand on the shoulder of giants. Okay, so that's what our APIs are for. So how do you use Google APIs? So since many of you are in the GDG, I probably don't have to spend too much time on this because you're already Google developers, right? But for those of you who have dialed in, maybe you're not developers, maybe you're a developer that have never used Google APIs before. What is the process? Okay, so the first thing you do is you go to console.cloud.google.com. That's easy. It's just a website. So that will take you to the cloud dashboard. Once you're there, you have to sign in. Of course, if you're already signed in, that's great. You don't have to do it. But yeah, so typically you would sign into your Google or Gmail account. By the way, not if your company uses G Suite, if they're a paying customer, your administration, all of your sysadmins need to enable you to be able to create developer projects. And if they don't, then you just have to stick with your Gmail address to do your coding with. Okay, so just keep that in mind. You may not have developer projects turned on if your company is a G Suite company. And then for every app you create, you need to create a project. Okay, and then so a project sort of like you can think of it as like a container for all the resources that you're going to use for an application. So one of the things that you're going to do is you're going to enable which APIs you want to use. I want to use the machine learning APIs. Maybe I want to store some of this data into Google Cloud Storage, or maybe I want to read some of my images that are sitting on my Google Drive. So you just enable all the APIs that you want to use. We don't enable them all by default for obvious reasons, right? We can't offer every application, every access to every API. So you need to turn them on. Some of them require billing. So all of the cloud platform ones do require billing. So I'll get to billing in just a moment in the sidebar here. So once you turn on billing, you can turn on the cloud APIs and then download the client libraries for whatever language you're using. So most of my examples will be in Python and JavaScript tonight, but we support lots of languages. So I have another slide on that just to show you at least the set of languages that we support primarily. Then you have to create your credentials because in order to talk to an API, you need to have something. To prove that you're a user, to tie it back to your project so we can bill you properly and all these different things. Then you create your application, and then of course you have to run your application. And if you do try to access, user-owned data, maybe you want to, write some results in a spreadsheet. But maybe the spreadsheet is a document that's owned by a human user, whether it's you or somebody else. And for security reasons, that user who owns that document needs to give your application permission to actually write to it. And things like that. You need to have permission to, add files to your Google Cloud Storage bucket, add files to your Google Drive, to add new videos to your YouTube playlist. So all these are examples of user-owned data, and in that case, you need to authorize that. The data could also be owned by an application in the cloud or a robot user, so you may have to authorize as well too, but it's not explicit, it's implicit. All right, so before we move on, let's take a quick look at cost and pricing. So as far as pricing goes, anything in cloud platform is pay per use. So it's just like your water bill, your electric bill, your phone bill. Well, maybe not your phone bill anymore because we just have a monthly fee, right? So your water bill is, you just pay a few cents every time you use it. Same thing goes for electricity. So that's how it works. It's not really expensive. G Suite APIs are different. So in case you were wondering, that has a monthly subscription fee. So if your company uses G Suite, where the company provides you, your own corporate Gmail, Google Drive, Calendar, Docsheet, Slides, there's a monthly subscription fee with that. Most of us who are just, home users, we just have a Gmail or other Google account and we just use the free version. So the monthly subscription fee for that is 0. So the G Suite APIs you can basically use for free if you have a Gmail account. So anyway, that's an aside. We're mostly talking about GCP and cloud platform stuff. We also have a free trial. I would recommend that you hold off signing up for that if you're a new user to cloud. Just don't turn it on yet. because if you're just kind of fooling around, it's not serious. You don't want to start that clock. That is a 12-month clock. As soon as you start, as soon as you enter the free trial, it will expire in 12 months. And then maybe later on, you want to actually start using our cloud, then, you would lose that access to that money. So I would say, don't turn that on. Give us your credit card. It's okay. You're not going to get billed that much because we have an always free tier. So an always free tier basically means that most of the products in GCP have some sort of free daily or monthly quota, and you have to exceed that quota in order to incur billing. So we're not going to charge your credit card until you've used up that quota. So for example, we're going to take a lot of we're going to look at a lot of examples of using the Cloud Vision API. So you're going to see Vision as sort of like the number one API that I'm going to talk about in this talk, but all the other APIs have their own free quota. But for Vision API, for every API call that you make to a specific service, like I want to use the Vision API to tell me what's in a photo, that counts as 1 unit. Maybe I want to OCR and read text out of an image. Then I call that service in the Vision API. It's another unit of service. So every service gives you a free monthly quota of 1,000 units. So I can call the object detection Vision API service 1,000 times a month for free. I can call the OCR text detection 1,000 times a month for free, and then you pay like $1.50 for like the next 4,000 units or whatever. So $1.50, that's not too much, but and then like for other products, it's different. Like for Cloud Functions, if you're going to write, a Cloud Function, you have to call a function like you can call it like 2 million times for free every month. You have to exceed 2 million calls in order to pay. So generally, even though you give us your credit card, you're probably not going to be paying anyway. So that's another reason why you don't have to sign up for the free trial. Only do the free trial if you're ready to start actually using it for like real, okay? Because you can only get it one time and it lasts only 12 months. So just save it. Um, Again, the always free tier has to be exceeded in order for you to incur any kind of billing. So if you want to learn more about the free trial as well as the always free tier and what are the quotas for all the products, then you'll find it at cloud.google.com/free. Okay, so everything happens in the console, like I said. So we have the first thing that you should look at is when you go to the console, as soon as you pass all the stuff that you've pinned up at the top, you'll get to all of the services. Like I want to get VMs, or I want to run code on Cloud Functions. I want to use storage. I want to use some of the databases, and then this goes off the page. It just keeps on going down and down and down because the number of products is tremendous. Okay, so there's a lot of stuff to do there. So you configure each of the products that you're going to use. Every application has a project as a container for it, and then every project has a billing account. So here's your billing where you can set up your credit card. It's pretty easy. You can have more than one billing account. You can have a home billing account. You can have a work billing account. The free trial, by the way, is another billing account that you can have. If you have a student in school, we offer education grants, so students can use our cloud for free. So that's billing. The other item is if you are in school and you're doing projects with other students, or you're working in a work group and you have other colleagues, the IAM or Identity Access Management tab will let you manage all the users. You can tell them what kind of roles they have. Are they a viewer? Are they an editor? Are they an owner? Things like that. And then the last part, the most important one, is the API manager. So this is where you sort of like, this is your developers console. This is where you enable all the APIs you're going to use. And it's also where you get the credentials that you're going to use to access our APIs. So that developer console looks like this. So to save you one click, you can just type console.developers.google.com, go straight here. You don't have to go to console.cloud first and then click through. And but of course, developers is a longer word, so you can kind of decide what's your trade-off, a mouse click or a couple of extra keys. So here on the dev console, there's a couple of things that you're going to do. So the first thing is this dashboard you see here. So this basically gives you some application statistics, like how much traffic is your app getting, how many errors is your app generating, and roughly how long does it take for your app to respond to your users. And then down below is a list of all the different APIs you've enabled, and it also tells you some, sort of like similar traffic information, but split out according to what APIs you have. And then you can, disable those APIs if you decide not to use those anymore for your apps. So that's the dashboard. And then the second thing is the library. So when you click on that tab, it'll let you enable and disable which Google APIs you want to use. And then the last tab is the where you go and create your OAuth credentials or your API key if you're using an unrestricted API. But anyway, you create all your credentials at the credentials tab. And then generally, if you create something that's OAuth related, we're going to ask you to download a file that you're going to keep with your application code. So they can take that data, your client ID, client secret, or your private key pair, and exchange it for an access token with which you can use to talk to our APIs with. So if you want sort of like a longer overview on this, I made a video for it. Oh, by the way, anytime you see a blue box, it means I made a video for it, just to help you go back and review it. So that's a developer's console. So again, most of my demos are going to be in Python and JavaScript tonight, but we support lots of different programming languages. If you're only going to be using GCP and none of the other Google APIs, then you can go ahead and download client libraries for whatever products you want to use at the bottom link here. However, if you're going to be using non-cloud APIs like G Suite APIs, Maps APIs, YouTube APIs, Analytics APIs, then you have to download what we call these platform client libraries, because only the GCP products have a product client library. And for those that don't, you have to use a platform client library, which works for multiple APIs. A lot of times I just use the platform libraries for GCP tools as well too, just because I'm moving back and forth between cloud and non-cloud. It's just easier if I keep my code consistent. But if I only have a GCP only code, then I go and use the product client libraries because they're the newest, they're the most maintained, and they're the most specific for each product. But anyway, here's a list of all the different languages that we support. So there's, we support most major languages that developers use in industry today. Okay, so let's talk about machine learning in particular. So Cloud Vision lets you understand the content of an image. It will let you identify and detect objects, which are called labels. It'll let you extract text like OCR. It'll detect landmarks, corporate logos, facial features, product search, as well as explicit content. One of the cool things about the Vision API is that there's a live demo, I believe, on the homepage. So if you go to the homepage, it will let you upload an image from your desktop or from whatever computer you have, and it will actually analyze that image for you, tells you what it sees in that image. But better yet, for those of you who are developers, it will show you, what is the JSON payload look like for the request, what is the JSON response coming back from the API, so you can kind of figure out how to parse it. And it also goes, it also has tabs for each of these individual features too. So it's a really, really good demo. So let's take a look at this. Let's dive in. So here's your first Python code sample. Again, if you don't know Python, just pretend this is pseudocode. So we have an image. It's sitting in Google Cloud Storage. So I have a short link here. If it was on the web, then I would have HTTP here. And you can also tweak this code to support uploading of a local file from your computer as well too. The client library is very flexible. So we import the Vision client library with the line at the top. Then I create a client to talk to the API with, and then I pass in a link to the image wherever it is. And then I just say, hey, please detect everything that's in here, and then pass in the image to the image variable. And then once I get a response back from the API, I just print out, so what are the objects, and then what is the confidence score that that object or that label applies to this image. Okay, very basic. This is what, like 8 lines of code, 9 lines of code. Is very, very short. You can get going very quickly with our APIs. So that's another reason why I'm using Python, because you can actually have an entire code sample fit on one slide. Okay, so here's the photo online. It's a picture of a street life in the Shanghai. And here are the labels that the Vision API has identified, as well as the confidence score of the likelihood that that item's in there. And I'm going to link you to this code lab. So if you don't know what a code lab is, it's basically an online tutorial. It's self-paced, right? It's free. And in half an hour, you can play with this app as well as 3 other apps in, again, 10 lines of code. You can pretty much absorb this whole thing. The other ones are about the same size as well. So I'll give you another link to this a little later on, but you get 4 examples in that particular tutorial. So let's look at the next example, which is I'm going to try and detect some text in an image. So this is a different image, and here's my code. And this time I'm going to detect text. So that's what I'm requesting. And then I just print out what text I found and then where it's located. So that's that example. So here's the image, and here's the text that it sees, and it actually tells you what is the text, and it also tells you the bounding box, the polygon where that text was detected. And then another link to the code lab. And then here's the next one. Okay, moving on to the third example. So this is where I'm using it to detect landmarks. So you notice that the code is all very consistent, right? I give it an image, I create a client, I pass the image location, and then I call whatever service I want. Okay, so landmark detection now, and then print out the output. Okay, in this case, this is, obviously it's the Eiffel Tower, but it also recognizes where the Eiffel Tower is located. And so it tells you, the landmark that's detected as well as the confidence score. This time I just returned the, um, the real number instead of a percentage. And then the bounding box of where that landmark has been identified. So anyway, so here's the code lab again. So you do those two, the landmark and the OCR one, and then you also do the street market in Shanghai, and then you also do these other pair of my coworkers being silly, but it's measuring facial features. So this is not facial detection. This is just facial features. Is this person happy? Are they sad? What's the emotion that they have? So you can detect that. So you can do all that at the Cloud Vision code lab that you see there. And then other code labs are found at this short link down at the bottom. So there are all the other cloud ones. Okay, so lots of tutorials for you to use. This one will take, less than half hour. I'd say about 15 to 20 minutes, especially if you go with cut and paste. So moving on, we also have the natural language API, which will help you understand the structure and meaning of text. So it does things like sentiment analysis. Is this positive or negative? It can classify content, extract entities. It can also do syntactical structure, like is this a noun? Is this a verb? And it supports multiple languages. So here's an example of some text I have up at the top. So I'm going to detect whether that's positive or negative. So you can read through it and kind of figure out in your head whether you think this is positive or negative. So I'm going to ask to analyze the sentiment. And then I'm also going to classify this content as well. So I'm using 2 out of the 6 features that I just talked about on the previous page. So for that text, if you guessed it was positive, the answer is yes, because this score is between 0 and 1. If it was negative, it would be between 0 and -1. All right, but the score is pretty low, and the reason for that is because it only found one word that told it that this phrase was positive, and that's this one word here, love, right? However, the magnitude indicates the strength. So is love a strong or a weak word? Obviously, it's a strong word, so that's why the magnitude is higher, okay? But if I change love to like, my score would stay the same because I only have one word that says this is positive, but my magnitude would drop. And then if I added more words that indicated it was positive, then the score would go up. So you can kind of get how this works. And then as far as categories go, it's 76% chance it's internet and telecom related, 64% chance it's computers and electronics related, and then 56% chance it's news. All right, so moving on, we have speech to text and text to speech. So speech to text will take an audio file and transcribe it into strings that your application can process. And then text to speech does the opposite. It takes a text string and then it puts a voice behind it. So let's take a look at these. So this one is I took the same text from the natural language API, and then I'm going to generate generate an audio file out of it. So I'm going to run this. No, this one extracts. This one basically transcribes that speech audio file to text if I had an audio file that had that. Okay, so that's the only demo I'm doing today. I sometimes have a text-to-speech demo, but it just works the opposite way. Okay, so anyway, so that's that. Then we have the Video Intelligence API. This is similar to the Vision API. The only difference is that instead of a single image, it will scan every frame of a video. So, obviously, be able to extract objects out of it. It will actually tell you when your camera angle changed and things like that. So it tells you a lot of different things about your video. So here's an example where I'm going to request the objects be detected in this image, as well as I want to transcribe the speech in the video. So I call the API, and then I display the output here. So I'm gonna display all the objects, and then I'm gonna display all the speech transcriptions down at the bottom. So here's the video. So I'm gonna click play. And I'm not sure you guys could hear the sound coming out of that, but basically the guy goes, "You need a hug. Come here." Okay, so it says it's probably vacation, it's probably fun, confidence scores, and then the speech transcription. So that's the Video Intelligence API. There's also an API for Google Translate. So this is, it's pretty basic. It's exactly what you expect. So this demo, this code sample is in JavaScript. instead of Python. So you just import the Google Translate API, you pass in some text and then the target language, and then you say, translate this text from English to this language, which is Russian, and then there it goes. Then you just output that. Some other things you can do with Google Translate, you can just have it translate the text and tell it to auto detect the language instead of specifically saying what language. You can also get a list of all the languages that are supported, and then you can also just see if I can detect what language this text is in. So a lot of different tools that you can use with Google Translate. All right, so that's it as far as sort of like the basic building block APIs. Now I want to switch gears a little bit and talk about AutoML. So all of these APIs that I just discussed, translate, vision, natural language, and video intelligence are backed by these pre-trained models, like I said, right? It's great because you don't have to worry about the training, right? That's very useful stuff. However, maybe you have a special use case. Maybe your industry, you work in the medical field, and maybe all of the images that you work with are medical images, like maybe MRIs or X-rays and things like that. Or maybe your company works in construction and everything's a construction blueprint. Our pre-trained model, while it can recognize a bird, a dog, a plane, a cat, a puppy, and a muffin, it's not trained to do medical images or uh, construction blueprints, right? So you can use the AutoML feature of the Vision API to customize our API for that type of data. So without much machine learning expertise, you can take our API, you can take our pre-trained model and customize it for your data set, all without having to know a lot of machine learning. Okay, so that's why you're moving in the same direction as a data scientist, because you're now doing training, but you don't have to know all of these, the math behind it, right? You just provide us a lot of data of medical images, you provide us a lot of construction blueprints, and then you just let it run for hours, build up a tweaked version of our model, and boom, off you go. You have a new model with which you can ask for new predictions on. Okay, so how does it work? It's pretty basic, as you expect. Since you've already seen kind of how it works, you have to get your training data ready. You have to create your data set. You have to import all the training data into the data set. Then you train your model. Then you test your model, and then you can make predictions on it, just as if you did it using TensorFlow or PyTorch. So it's pretty great. Um, so that's AutoML. And then I also mentioned the ML engine. So, one more step to the right, if AutoML still doesn't do what you want and you're ready to start building and training your own models, but you don't want to think about the hardware behind it, that's what ML engine is all about, to give you that infrastructure. Okay, so that's it as far as machine learning APIs. For the last 20 minutes, let's talk about other APIs and then show you some inspirational apps. So Google BigQuery, so this is kind of machine learning. It's a little bit of machine learning in BigQuery, but the main idea is it's a tool to help you analyze a lot of data, like multiple terabytes of data, and get results back in seconds. Okay, so that's really the main idea behind BigQuery. Okay, analyze a lot of data in a very short amount of time so that you get results back in seconds, not hours, not days, not weeks. Okay, and especially for data sets, you just cannot get it to fit in a relational database. All right, so here's what it looks like. So I'm just going to look at, I'm going to show you some other examples, but the example I have in code here is analyzing all of Shakespeare. Now, Shakespeare back in the day, he really didn't have the ability to generate a lot of multimedia, so all of his works are in plain text. And so this is not an example of a multiple terabyte data set, right? If you took all of his words and squished them together, it's less than 40 megs of text, plain text, right? So it's not a lot of data. However, this still represents a task that you do not want to do as a human. So if somebody said, go to the library or go online and get every single thing that he's ever written and then count up all the words and then sort and give me the top 10 most common words he used, that is not something that you want to do as a human. It's much better if you just issue an SQL call to go and do it, right? Then you can send this request to BigQuery and then display the results. So, if you already didn't take a wild guess, Shakespeare wrote the more than anything else, more than thou or, thy or any of those other older English words. All right, and BigQuery also has a cool web interface as well that you can use too, so that's pretty cool. So a lot of different ways that you can use BigQuery. So after the talk, if we have time, or if anybody wants to stay over, I'm going to show you a live demo of BigQuery. Not only this example, but a bunch of other public data sets we have. We have a lot of public data sets. So Shakespeare's one, we have like the Health and Human Services Neonatality Database, so that would be a demo that I would do. We also have like all of GitHub from 2017. We have all of Wikipedia from 2015. So we have a lot of different data sets that you can use. And so all of data sets that are hosted on BigQuery can be found at this link up here. One of the cool things about BigQuery is that you can use it completely free without even punching a credit card. You can actually use the BigQuery sandbox where every user with a Google account gets to make 1 terabyte of queries per month absolutely free. So it's great. And then we have a bunch of other data sets that are not in BigQuery, but you could import them into BigQuery if you wanted to. And then, of course, in today's day and age, the reason why I'm not giving this talk to you in person is because of the coronavirus. So, of course, there's a lot of public data sets there. The most well-known one probably being the John Hopkins one. So that's a link directly to that data set. But you also, I'm giving you a link to all the other COVID-related data sets as well, too. And then if start digging around Google Cloud, you may discover that we have a life sciences API. So if you're actually doing genomics and sequencing, that is an API that you would be using. If you're working in the healthcare industry where you are having to move around medical data between different systems, different medical systems, like X-rays and MRIs in specific formats like the DICOM format, which is pretty popular. That's an API that you would use for that. So these are just links to other, lots of different data sets you can take a look at. Huh? All right, you can still hear me, right?
Yeah, you're good. Go ahead.
All right, great. All right, so let's moving on really quick. I apologize. I wasn't aware that you guys actually were seeing that that dialogue because you can have a really small computer that you can get online. This F1 micro device, you can get it for free every month. Yeah, so that's you have to plug in a credit card, but everybody wants to be a VM a month basically. And if you do need to have, if you have a big workload and you need to have a giant machine, you can get all the way up to 416 vCPUs, 12 terabytes, almost 12 terabytes of RAM, and 256 terabytes of hard disk. So it's a pretty large machine, pretty expensive. So just got to be careful. You can attach GPUs and TPUs to it, and then we support most versions of Linux as well as Windows Server. If you are doing machine learning and you're getting your own hardware, you can attach TPUs to it. So the API lets you put together a VM along with TPUs to help you with your training. So if you can't see the link to the blog post down at the bottom, but when you get the slide deck, you should be able to get access to the. If you don't see the blog post, just let me know. But if you go to our website, it'll link you to the blog post. But basically, they sort of like did a comparison where if you use a TPU pod, a pod of TPUs, it can be 27 times faster and 38% cheaper than using 8 GPUs. So TPUs are processing units especially made to do machine learning training with. Okay, there's also App Engine. So if you have a great app idea, but like if you get a VM, guess what? You have to think about operating systems, then database servers, then web servers, and all these things. So maybe you don't have time for that. Maybe you just wrote an app and you just want to upload it to the cloud and run it. So that's what App Engine is for. Then we also have Cloud Functions where maybe you don't have an entire app. Maybe you just want to deploy like small little functions or microservices. So that's what Cloud Functions are for. And then there's also a mobile version for Firebase because Firebase is our mobile development platform. And then the third type of tool we provide is if you have a container and you don't want to manage the container yourself, or maybe it's too difficult for you to set up Kubernetes because your set with your container is not that complicated. So Cloud Run basically helps you run containers serverlessly. But if you do need custom hardware, okay, because Cloud Run will run on a specific hardware set that we give you. But if you need things like GPUs, or you need to run on a VPC, then you can run Cloud Run on Kubernetes, our managed Kubernetes service called Google Kubernetes Engine. So it's another option for you. And then Cloud Run, you can also, it's compatible with Knative, so you can actually run it on your on-prem Kubernetes setup as well too. So it's very flexible. So for storage, there's Google Cloud Storage. So that's our giant data lake, where all of your data rivers flow into your data lake. This is where you put your multiple terabytes of data, and then you just say, hey, which GCP service do I want to use? And you just point them at your cloud storage bucket, and you can process it immediately from there. So it's sort of like, not only is it for data storage, but it's also your entry point into using different cloud services. Now, instead, if you're looking for something more like a NAS, like an NFS-mounted file server in the cloud, then that's Cloud File Store. So as you can probably guess, that's a completely different use case than like massively putting your data in one giant archive. So that's that file store. We also have relational databases. So if you want to use MySQL, Postgres, or SQL Server managed in the cloud, so you don't have to do it. We also let you choose your hardware configuration as well too. So that's that. In addition to SQL, we also have NoSQL, so that's Cloud Data Store. So it's very fast, very scalable, fully managed NoSQL database. However, don't use it. There's something better coming up in the slides, but I at least needed to tell you about its existence so that you have some context. So let's take kind of like a quick detour and talk a little bit about Firebase, which is not quite part, it's not quite part of cloud. It's sort of its own standalone product, but we do have a pretty close relationship with the Firebase team as well as the Firebase products. So many years ago, Firebase was a separate company, and they created this awesome real-time database. It's real-time because as a client, if you create a listener to objects that you care about that are in the database, anytime that data is updated, all the clients are notified. So that's why it's real time. People love it. People used it for developing all their mobile apps. It was great. And what happened was, after Google acquired the Firebase company, we took the real time database and made it sort of like the center stone of our next generation mobile development platform. We added all these other tools around it to help you make your mobile app successful. Things like crash test reporting, virtual device testing, app indexing, mobile analytics, deep linking. So all these different features, coupled with the real-time database, make it our official mobile development platform. And it's independent of whether or not you're developing Android or iOS, and more likely both. So anyway, so if you take the real-time features of the Firebase database and merge that together with our fast, scalable NoSQL data store, you have our next generation NoSQL data store called Cloud Firestore, which has a little bit of a product rebrand to indicate that it has Firebase features added to it. So this is the NoSQL data store that you should be using. There's still a lot of people that kind of like the simplicity of Firebase, and they don't need the massive scaling. So you can still use the Firebase database, but most developers, we kind of recommend that you go to Firestore because that's the next gen, basically. So that's the NoSQL database that you should be using. And then there's a link there. Besides the homepage to Firestore, there's also a link in case you're trying to figure out which of the two Firebase databases to use. Okay, jumping over to G Suite really quickly, we have the spreadsheets are the most programmatic out of all the different Office productivity tools, and it's with oldest APIs along with Google Maps. So we're on V4 of the API for Sheets. The main idea behind it is you might have a lot of data sitting in a database, but it's not really visual, right? You're not going to go and tell your boss to select rows out of a database just to find out some information, right? It's much easier if you present your manager with a spreadsheet. And if you're using the API, you might as well tell it to make a chart too, right? So anyway, so down at the bottom, there's a link to a code lab for the Sheets API. My manager at the time wrote this cool code lab, also less than half an hour. It's a Node app that lets you create a customized reporting tool based on toy orders from a fictitious toy manufacturer. So that's pretty cool. And the reason why I tell you about this is because the first code sample I'm going to show you reuses that database. And what I'm going to do is I'm going to transfer all of the data from that SQL database into a spreadsheet. So the first 6 lines of code will read all the rows from the database. It'll add the column names because that doesn't come out of my select call. So I add that as row 0 in all of my data. The second chunk of code creates a brand new spreadsheet, and then the third chunk of code uploads all of that data to the spreadsheet starting at cell A1. Pretty basic. There's a video on that one, so it's pretty cool to be able to migrate your SQL data to a sheet. Then we have the Slides API. I'm not going to talk too much about it, but you can already guess that it lets you programmatically create and manage slide presentations. Similar kind of reason why you would use this. So, you can think of it from, okay, well, a spreadsheet is more visual than a database. That's great. But even that's not as visual. Like if I'm going to present to my boss, I'm going to use a presentation, right? So you can actually take that data as well as any kind of at charts or whatever, and you build a slide deck out of it. So another coworker of mine wrote a different Node app where you can use BigQuery. We talked about BigQuery, the big data tool, and analyzes all GitHub projects and kind of figures out, so how many projects are using the Apache 2 license? How many are using the MIT license? So it's a good way to kind of like get your feet wet with using both the Slides API as well as BigQuery. Another use case is maybe, I have 10 customers. I want to use the same slide deck, but I want to customize each slide deck for every customer, right? Well, I don't want to create 10 different slide decks. I want to create one master template deck. And then I want to be able to read all my customer information out of a spreadsheet or Salesforce or something. And then I can take that data and then customize each of my presentations out of it. Maybe replace the company name and my client name, as well as their corporate logo and things like that. And then another coworker of mine wrote this cool Node tool. As you can tell, I'm the Python person, they're the Node people. So it's a good balance. So they wrote this cool tool in Node that lets you write an entire slide presentation in Markdown, and then it auto-generates a Google slide deck out of it. So it's pretty cool. It's got a lot of stars. So anyway, so let's take a look at some code for this app. So I'm going to replace all my client names. This is a variable that I have in my master template. I copy the slide deck, and then for all of my copies for each of my clients, I'm going to replace their client name, and then I'm going to replace their corporate logo with the under logo variable that I have in the master template, and then I just replace it and I give a URL for that image. And then I say, hey, Slides API, please make all these changes globally to each slide deck and go and do it. So this is, of course, just for one slide deck, but this is going to be called in a for loop to do the other slide presentations. And there's a video on that as well. Here's another one where I'm actually going to import the data from the Google Sheet and the charts into a slide presentation. So it's going to be very similar. And then I made a video for that as well, too. All right, move on. I'm going to talk a little bit about AppScript. This is another serverless tool that we have. It's a customized serverless JavaScript runtime, and its main purpose is to help you automate things, and it helps you extend the features of the Google editors like Google Docs, Sheets, and Slides, as well as Gmail and Forms. But it also connects to other Google services. In fact, it'll connect you to at least 40 different Google services, but it also lets you connect to other services. There's a JDBC service, so you can talk to a database. There's a URL fetch, so you can talk to other services that are online. So this is a little bit higher level. It's not the same as the API code that I've been showing you over the last half hour. So Google Apps Script, believe it or not, some people feel it's a secret, but it's not a secret. I don't know how many of you have ever heard of AppScript before, but apparently a lot of people have not, and we launched this in 2009. So it's actually 11 years old, so it's not a secret, nor is it well kept. But what it is it is JavaScript, but it's a lot less like using APIs that we've just been showing you. It's more like you're accessing APIs via objects that are built in. And the best part is you don't have to write any of the security code. So I didn't show you in the code samples with the APIs the security code that you need to have. And that's taken care of for you by AppScript. So AppScript is a higher level form of programming. It is server side, so it runs on Google servers, but it is not like, it's like Node because it's server side, but that's where the similarities end. Node is basically used for fast, asynchronous, event-driven processing and other stuff. But AppScript is basically JavaScript, like a programming language that runs on Google servers. So here's your hello world. The one line. And notice that I'm just talking to a spreadsheet and I'm just adding hello world to cell A1. So the one liner, I just broke it up into 4 lines so it's easier to read, but I'm going to connect to Google Spreadsheets. I'm going to get the active sheet. I'm going to get cell A1, and then I'm going to write hello world into it. And then when you run it and you go through the OAuth prompts and give permission to this code to access your spreadsheets, when you're done with that, then you will have hello in the first cell of your spreadsheet. And that's really exciting because guess what? You did not type that in. Code did that. And then so that's going to make you start thinking about all the crazy different things that you can do with this just by this one example alone. So it's a pretty great hello world example because you can visually see it. It's more exciting than just seeing output on a terminal window. So anyway, so there's a video for that one. But that's, hello world is great, but that's not real data, right? So here's some real data. So I have an address here. It's the Google office in New York. And so I'm going to do something with cell A2 on the next slide. So I'm going to blow up this app from 1 line to 4 and make this a little bit more useful. So with the help of Google Maps and Gmail, I can connect to the spreadsheet again. This time I'm going to get L2, but instead of setting the value, I'm going to get the value, which is the address, save that in a variable. Then I could say, hey, Google Maps, can you make me a map and put a pin or a marker on this map? And then line 4 is, hey, Gmail, can you email my friends so they can come join me at the Google New York office for lunch? And then that's what's going to show up in their inbox. So, it's those 4 lines of code that does something much more useful than hello world, but it still only took 4 lines of code. How much easier can it get, right? So that's why AppScript is so powerful, because in not very many lines of code, you can get a lot done. And like I said, doesn't have to be Google services. I can call out, to a SQL database with JDBC, or I can use your URL fetch to talk to any other service online. And then I can also use the OAuth2 library to authorize to different APIs and things like that. So if you wanted to build this app line by line, there's a code lab for it at the bottom, and then there's also a video. Okay, so where can you take that? Maybe you want to write an app for people where they want to visit all 4 of their customers in New York. Well, because you're connecting to Google Maps, now you have access to, driving directions, walking directions, public transit directions. Maybe you manage a user group or a book club or something like that. Very, very useful to be able to do something with that. So you can start with those 4 lines and build something that's really useful. How is this related to machine learning? Well, so we've using AppScript, you can create what is called an add-on to Google Docs, where this one will analyze the sentiment in a Google Doc. So I just use Alice in Wonderland. I cut and pasted something out of some passages out of the book, and then I can highlight it, and then I can run this add-on that I wrote in Google Docs to call the natural language API to detect whether or not this text is positive or negative. So if it's positive text, then it's going to be highlighted in green. And then if it's negative text, then it's going to be highlighted in red. So that's also another code lab that you can build. But just to give you an idea of what it looks like, in this particular case, I'm using an API key. Some of the machine learning APIs let you use that instead of OAuth because it's generic data. I'm just passing in some text. So I pass in, I call the API. Here's the document that I'm passing it. And then here's where I'm going to call the API with URL fetch. So I mentioned you can call an outside service. Even though cloud is cloud, this is still considered a service. I parse the return value, and then you take the score, I have the rest of the code, but I take the score and I highlight the text in color, depending on whether the min is positive or negative. So that's it for that. And then you can create more add-ons with AppScript. So all the different editors you can tools with it. So let's move on to some and wrap things up. So what can you do to use all of cloud? That's TP as well as G Suite. So one of my colleagues added Cutela's to his Gmail by analyzing G Suite data using GCP and a little bit of machine learning. So Gmail does a great job using machine learning to filter out all my spam. But even with my non-spam, maybe he only cares about certain messages. So when he wrote this app, he said he only cared about emails that have attachments of pictures with birds in them. Okay? I think he got too many recruiter emails, and he told them if they wanted him to read an email, they had to attach a picture bird to their email or something like that. So what did he do? He wrote an app such that every time he got a message in Gmail, that would send off a notification to Cloud PubSub, which is our message queue system. So think of it as Kafka in the cloud. So for every message, it kicks off the notification of PubSub. PubSub will call a Google Cloud function that will extract the attachments in his emails. It will call the Cloud Vision API to analyze the objects in. It gets all the labels back, and if bird is one of the labels, then he will call the Gmail API to star that message without running any kind of code. When he logs into his Gmail, some of his email will have stars next to it. So that's one example of adding custom intelligence to Gmail. And then there's here's a link to find out how you can forward Gmail stuff, and here's a link to tell you how someone can call a cloud function. Then here's a blog post, and then here's the GitHub repo for his code sample, so you can take a look at it. The next example I wrote, which is going from big data analysis to slide deck by accessing GCP tools from G Suite. And so big data, I told you about BigQuery. It's a great tool, but at the end, when you're done with your query, you downloading as CSV. Again, that is not really visual. You can stick it into a database, or you can have CSV, but not visual, right? So instead of doing that and stopping there, I will say that that is just 80% of all the work, like these stairs here. I could use them, but it's not visually appealing. Instead of CSV in a database, why don't we put it into a spreadsheet? Remember, more visual, right? And might as well tell it to make a chart. And then you might as well import the data and the chart and build a slide deck out of it, right? So, I mean, you're just kind of like doing the last 20% now. You've done the 80% hard work. If you got to tell your boss what you've done, you might as well make it a slide presentation. So this is an AppScript app. And so from AppScript, I call into BigQuery, and then the results come back in Google Sheets, and then I tell it to make a chart, and then I make a slide deck. I import the data and the chart, and what I've done is I've from big data all the way to exec ready slide presentation, all in, if you actually look at the source code, it's less than 100 lines of JavaScript if you strip out all the comments. And then I have a code lab that you can build this line by line. And then there's also a video behind this one as well too. All right, last example is one that I just finished. I just published it yesterday. So this is a cloud image processing workflow where you're analyzing and archiving G Suite images using GP. So the thing is, maybe you work in architecture, maybe you work in the media, maybe you work in manufacturing, all right? These are industries where you tend to have a lot of images or video or multimedia sitting in your Google Drive cluttering things up, right? You have a lot of stuff in your drive. I can't even find my files anymore because I have so many folders with videos in them, okay? Well, why don't we move that to colder storage to get it out of my drive so it can actually work again more productively and put it in colder, cheaper storage like cloud storage. It's cheaper because you're not accessing it as much, right? And then if I'm going to do that, I might as well pass it to Cloud Vision to analyze it so I can catalog what I'm saving and archiving. And then why don't I just have all that going into a spreadsheet to help me realize how did I clear off my Google Drive and what's in archive, and give me a link so I can actually go and find them on cloud storage. Okay, so that's kind of an interesting workflow where I have images on Google Drive. I download those and then upload them to cloud storage for archival reasons. While I have the binary, I might as well send it to Cloud Vision and get some analysis on it and then record the results into a spreadsheet. Okay, so that source code kind of looks like this. I have individual API functions, one to download from Drive, one to upload to cloud storage, one to pass the data to Cloud Vision to get labels out of it, one to add a row to a spreadsheet, and then my main just calls each four of those one at a time. And boom, I will have a spreadsheet that you see here. Oops, that you see. I shouldn't have done this, that you see here. Okay, so if we have time afterwards, I'll run through that demo as well too, but let me kind of wrap up pretty quickly here. So the code lab is now published just today, and then the source code was uploaded yesterday, so this is pretty fresh if you want to try this. This code lab is a little long though, because you have 4 APIs, so it's a little bit more than hours, and there's a lot of reading because I'm very verbose. All right, so wrapping up. So machine learning, again, is being able to solve harder problems by making computers smarter. It's not just code anymore. It's code plus experience, right? One of my coworkers basically says it's using data to answer questions. So how do you do machine learning again? Well, you have to collect the data, you have to build and train your model, then you have to validate it, then you can use your model in the inference phrase to make predictions on new data. Do you have to have a lot of experience? No. You can use our pre-trained models uh, that back our APIs. Do you still need to have a lot of machine learning expertise to do training? Not if you use AutoML. And then once you're ready, build your experience in ML, get familiar with it, and then build your experience, and then you'll be ready to use, PyTorch or TensorFlow or things like that. All right, so some resources. So if you want to learn more about coding G Suite APIs, there's the home page for all the G Suite APIs. Here's all of our GitHub repos, and here are some videos. Then similarly for GCP, here's the machine learning building block APIs. Here's the GitHub for all of our code samples, and then here's the YouTube channel for all of our cloud platform videos. Your next steps are to start playing with the APIs. Once you're ready and you want to try and do training, start playing around with AutoML to kind of train your own data, and then get some hands on doing machine learning code labs, and then you can kind of explore, do Kaggle and Colab to start doing TensorFlow and PyTorch and things like that. And other Google APIs you may want to consider, I already mentioned Firebase. We also have Google Data Studio, so that if you have lots of data, but you want to build a beautiful dashboard, Data Studio is our free tool, our free dashboard building tool. So it's pretty cool. If you want to build a voice-driven app, you can do Actions on Google. That's where you build it using Dialogflow, and Actions on Google for apps that run on the Assistant, which run on a Google Home or Home Mini or Nest devices. YouTube has APIs, Maps has APIs. If you want to build mobile apps that run on iOS and Android in a native way, as well as the web, but you only want to write it one time, that's what Flutter is for. And then last thing, if you like comics, and if you or your students, since I'm talking to faculty, if you want to learn more about machine learning, but in a comic book format, just go to cloud.google.com/products AI ML comic -1 and -2. So there's two comics. So that's what this is. It just means -1 and -2. And then that is it. So that is my Twitter in case you need to reach me. That is also my Gmail in case you want to email me. The link for the slides as well as the barcode is here. There's also, again, a link and a barcode to the open doc. My daughter says hello. She likes to draw anime. She's funding her way through college, so you can go look at her website. And if you notice the progress bar is going on all on the bottom, guess what? That is a Google Slides add-on, because I don't believe PowerPoint or Google Slides has a progress bar. So my colleague wrote it using AppScript, and this is a Google Slides add-on. So you can find out more at that there. I think it's a blog post and video as well. So I'm going to say thank you to Raju for letting me run over by minutes. I'm going to stop and take questions, and then if people want to stay later, I can run through some code demos as well too. So thanks a lot, Raju.
Oh, thank you, Leslie. It's great presentation. As people have been saying, a great lot of information. I know there is a lot to cover, and thanks for taking the time and going through that. There are a couple of questions we can take for folks. I know we are over time, but as you can see, Leslie has been doing it at a rapid pace. Really appreciate he taking the time and putting the effort for going through all this and sharing tons of resources. As I mentioned, we'll be sharing the slides and we'll be also sharing the recording and all of that stuff. So there are a couple of questions. If people want to hear and listen to that, we can be fine. And I have time, as Wesley pointed out, like want to wait for the demo, that's fine too. But if you wanted to have a hard stop, feel free to disconnect. I have a couple of questions. I'm going to read them to you. Wesley, you might be seeing them as well. The first one comes from Kaniksha. What is the best mechanism to deploy models, schedule ML jobs, and monitor different runs and manage different versions of ML model? So quite a question, quite a bit of that.
Well, that is quite a bit. Since again, I'm not a data scientist, I don't know the best ways. What I do know is that the ML Engine product does a lot of this sort of like management for you. So if you go back into the slides and go to the ML Engine slide, it's where you don't have to worry about the infrastructure and things like that. And you know, we give you the infrastructure to build and train your models as well as deploy them. So I would imagine that one of the features that it provides is the versioning stuff. So you can actually probably keep more than one version of your model, and you probably can specify which one is live. So for example, if you made a tweak to your model and maybe it wasn't the right thing to do, you may be able to go back to a particular version and revert back to an older model. But I'm not 100% sure because again, I haven't used that product, but I'm not a data scientist, so I'm not the best person to answer that. But that is just sort of like what I'm feeling as something that would make sense as to the product features of ML Engine.
Yeah. So maybe a couple of more questions, two questions, maybe we'll take it. And if you have time, we can take more if people have, but as some more questions have started trickling in. Another question is Cloud Firestore a standalone database, or is something only exist in the services with Google?
It is, you have to be a Google Cloud customer to use it. So in that sense, it is not standalone. It's part of Google Cloud, and it's part of the billing process that I mentioned. You have to create a project, and you have to enable the API, and then you can go and put data into it. You can query data out of it, but you have to have a billing account because you have to pay for not only the storage, but also network traffic to and from it. but it is standalone in that you don't have to use any other Google Cloud products. So you don't have to use VM Engine. You have to use VMs with it. You don't have to use App Engine with it. You don't have to use Firebase. You can just use it as a database, and if that's the only cloud service you use, that's perfectly fine too. So it is not tied to all the other Google Cloud products, but it is part of the cloud platform. So it's still sort of controlled by the same billing mechanism that we have, and you still have to have a project and things like that.
Okay, great, great. Last question from Irfan. Does the text ML API also dig word categories like phone numbers or name or city, country?
So so that would be the natural language API. So the natural language API has a number of features. I am not sure of that exact feature, but one thing it does have is the ability to understand the textual context. So here I'm going to go back to the slide that just describes what its features are. So if you're saying if what you're describing is related to content classification, where you're saying this is a news item, this is legal text or something, it may be able to do something like that. And then similarly on the entity extraction side, it knows how to recognize proper nouns. So it knows what what the United States is. It knows what Android is. It knows what China is. It knows what Delhi is, and Gujarat or whatever, right? So it knows proper nouns, but I don't know if it goes as in depth as your question was describing. If not, you may be able to use the AutoML version of natural language to further customize our natural language API to do exactly what you want. So I hope that helps.
Right. Great, great. So thanks. Thank you for Wesley for answering those questions as well. I want to take a quick moment to thank the GDG groups and the Cloud Santa Clara, which have brought us. Also, this was brought to by one of the two of our sponsors, Hacker Dojo, which is a co-sharing working place in Santa Clara, where we host most of our events. But now during COVID, we're just doing it online. And Big Data Trunk, which is our company, my company, where we provide a lot of cloud analytics data training and other kind of services and cloud migrations and consulting services to large clients as well. Finally, most important, thank you all for joining in and staying in, hanging in for the little bit of overtime, but I appreciate and hope you see the value in a lot of different features and resources and vast amount of the content which Wesley has covered. So thank you, Wesley. With that, I'm going to call it as the end of the session and go ahead and pause the recording.
A code lab to give you an idea of what it's about. A code lab, like I said, is really short. This one, it says 36 minutes, but really you can finish this in well less than half an hour. I think you can actually do this thing in like 15 or 20 minutes. The only kind of bummer is that with code labs, it's generally cut and paste. So if you just cut and paste and run it, it'll work. All right. But, obviously you can feel free to, once you get something working, then you can go and change the image, you can change the code and things like that. So code labs that Google makes will have this kind of format. So once you get past like the setup, and you can we show you how to turn on an API, we'll tell you how to turn on billing, you confirm the environment, like this is the Python one, but this actually code lab is available in C# as well as Ruby. The Node one is a little bit outdated right now, so I have to wait for my coworkers to update those. Sometimes I can't wait. I update them myself. Like this one actually got out of date, so I actually took this one and became owner of it, and I updated all the Python code. So and then it tells you like how to enable the API, and then how to authorize requests, and then how to install the client libraries. It's pretty basic. So you can just scroll through here. So once you're done with the setup, now here's the label detection. How do I detect images that are in the object? So this is the same market in China. And then this is the actual code, and I can actually run that in the command line after I show you this. But the font is much prettier when it's in color. So let me make it a little bit larger so you can see it here. It's a little bit larger. So yeah, so it's all colorized for you. It's pretty fun. And then it shows you the output here. I'm surprised it didn't. I guess you have to click to actually see the image. So the images are available as hyperlinked. But this is the next one, the OCR one, for that reading of that street sign or that that road sign. And then you just go through, like I said, these 4 examples, and then when you're done, it tells you congratulations, and then it tells you other things that you can do afterwards, what other resources that you can look at, and things like that. So that's the Vision API, Code Lab. The next is this one is the Natural Language API. This is the one where you're doing the sentiment analysis by building the Google Docs add-on. So this one is same thing. This one has fewer steps. There's less step on this one. So it leads you through writing this sample app as well too. So they all have that same look and feel. As far as like demo goes, so here's the one for the fish. I may be out of memory on my web browser, which is why I kept getting those errors. So maybe it's the one that's taking up on them actually. So let me see if I can get kind of work. But yeah, this is a live look. All right. I don't know how live data is. I think it's pretty live. Yeah, it says May 2020. So this is really, really accurate. You can zoom out and see kind of like globally what's happening as far as like fishing goes and where are the boats. And you can check different types of vessels and things like that. So, so anyway, so that is that's pretty cool. I'm just taking a lot of medical that one. This is the Vision Explorer. I haven't launched yet. I don't think I'm going to have enough memory. But once you bring that up, you can go through and just like scroll 3D and kind of like explore the galaxy of all these images. So that's pretty fun. If you click the identifying of the clothes, this is the code lab for the TensorFlow demo for identifying the clothing. So I mentioned this was supervised learning, where you say this is a shoe, this is a sweater, and you just go through step by step. It's a Jupyter notebook, so you just run it line by line. It's pretty great. It goes through all the clothing samples, and then you get to build a model, train the model, test the model, validate the model, and then you can go and make predictions based on any of the additional images. So it's pretty quick to go through. It's great because this is like a hosted Jupyter notebook that we have. So it's pretty awesome. So supervised learning that's what you're doing here. An example of unsupervised learning is where you don't have somebody to guide you to give you the correct answers. Like for example, I'm being told what is a shoe, what is a sweater, what are a pair of pants. So that's supervised learning. An example with the same data set of unsupervised learning is where you're just given all these photos and you have to say, can you just sort all of these so that all the shoes go in one pile, all the sweaters go in one pile, all the pants go in one pile? You don't know what they are, but you are basically looking at the data and finding out which ones look similar to each other, even though you don't know they're called a shoe, they're called pants, or they're called sweaters. So that's unsupervised learning, where you're not given the answers, you just have the data. And then there's also other machine learning models as well too that you can use. So that's that. And then as far as the Cloud Console goes, so this is an example of what your Cloud Console will look like. This is mine. So it looks like I'm going to get billed $1.62 this month. So I exceeded some kind of quota. I don't know which one it was, but I exceeded some kind of quota. So that's what it looks like. One of the cool things that you get when you become a customer and you have your console up is if you look at this icon here. I'm going to try and expand the size of the monitor here. I mean, inside the size of the text here is that this little icon that you have in the upper corner here, it looks like a command terminal. So if you click on that, that will open up a VM with a free shell down here. And then if it's not enough space, you can launch it into a separate tab. So that's what I've done here. I have my Cloud Shell, which it's basically like a bash shell, and it disconnects after like 3 or 5 minutes. And then I also have an editor here as well too, because I was looking at some code. So it's going to connect me back to my Cloud Shell. So let me close the editor here for a second. So in your Cloud Shell is where you can, code. It has like all, most well-known languages installed here. It has all of the Google Cloud SDKs, client libraries. Everything is basically installed here, so you can start fooling around before you actually build your system. So I think it's really small. I don't know if I can change the font. Let me see if I can change the font size. Okay, here's the text size. Let's make it large. Okay, so that you can see it. So everybody has a VM that has a home directory, and I have some demos in my GCP directory. Let's see, GCP. I think I have one of the Vision demos. So if I run Python, Python 3 label detect. Actually, let's take a look at it first. Actually, I can open up an editor for that. So let's take a look at our label detect so that you can actually do everything in the browser. You don't have to have a local development environment. So if I was to open up the label detect app, you'll be able to see the source code here. Again, this is pretty small. I can expand it, but you've already seen it in the slide, so I'm not going to do that. But you can actually run it here and then get the same results that we saw earlier. Oh, my permission is not authorized. I guess it's been a while since I authorized, so it's kind of a bummer. I was kind of hoping this would work. Let's see, it tells you that my thing is not installed. It's probably like looking up a environment variable that I don't have set up. So let's see, let's take a quick look because I love to debug. Live demos are great to debug because it actually builds character.